So now with that, I want to get into getting the other elements from our scene over here. So let's just go back over to Houdini. And let's just focus on this pyro sim. So I'm going to dive into my import pyro, like so. And here, I'm going to just select my camera again. And let's just grab a couple frames here. You can see I'm what I've done is I created my, let's just go. So here I've got my my VDB. It isn't a VDB yet. It's a volumetric simulation that I need to bring back out. Essentially what I did to create this, and we can go into all this stuff later, but basically what I did was I created a debris source based off of the initial fracture. These source points were what ended up creating the emission for our volume. And this is sort of what the emitter of that volume looks like. That emitter is then brought into a pyro sim, and then it is allowed to kind of like simulate as if it was a gas. And then when we're done with the simulation, I will import those fields that I need and bring them back out here and save them to disk. So this cache file was, I believe, pretty hefty, as they are. The pyro cache, if I right click and say properties, was about 44 gigs for 3 seconds of animation. That's because I'm working with a resolution. If I middle mouse click here, you can see I've got my 3 volumes here. Maximum resolution of 650 voxels. So along the long axis, this is all occurring inside of a box, but along the long axis, this is 650 wide. So when I import these fields out of my pyro network, I really wanted only 2 fields. Now, if you're doing something with combustion like fire or an explosion or something like that, you're going to also want heat and temperature. But in my case, I just wanted density because it's more or less just smoke. And then the other thing I brought in was velocity field, because velocity is, I use the velocity to actually drive my particle simulation in the last step. So I cached all this out. Caching your velocity vectors, because it's a vector, it's 3 times as much data as just a density, which is a scalar. It creates a gigantic file cache. So that's cool, but it's not in really any format that can be read by Cinema 4D or Redshift. So it's just a volume. You can see how these are green. These are Houdini volumes. So in order to get them to become, Cinema 4D volumes, I need to convert them to VDBs. I also don't want to send my velocity over. I honestly don't really, I find that smoke tends to be wispy enough anyways that I just don't need the velocity vectors. But if you do, you can bring them in as a VDB as well. So I'm actually going to get rid of those, and then I'm going to just bring my density over as a VDB. So to do this, I'm going to throw down a blast after my pyro cache now here. And these different volumes are stored as primitives. So if I go up here, you can see on the top of my group, from this drop down, I get a couple options. I can just select that I want to keep my density. So I'm going to select density. It's actually deleting the density. I'm going to do delete non-selected. So here's my density. And I just want to convert this now to a VDB. So I'll say convert VDB. And, well, actually, I'll just use a convert, like so, and wire this in. The convert will basically detect what the input is, and then I can say convert to VDB. So now we have a VDB, and if I middle mouse click, you can see that this, where it was once green here and said we had 4 volumes, now it is blue, and it says we have 1 VDB, and that is the density VDB. So that's really all that is required to convert this. So now, again, this is the same situation. We could scale this up inside of Houdini, or we could scale it up inside of Cinema. Either way, what I find is if I scale this up in Houdini, I'll show you what happens. Transform node, and I'm just going to grab this and scale it up by 10. You can see now that we've scaled this up by 10, it has become way more dense. And that's because the actual spatial density of this is remaining the same, even though the volume is the volume of it is increasing. So see how semi-transparent this was down here? When we get back up on this scale, it becomes way more opaque. So the way you can get around that is to actually manipulate the density of the volume to follow what you're doing with your scale. So if I throw down I'll do this using a volume VOP. And I'll just put this in here. And if I dive inside, volume VOP is very similar to how VOPs work with geometry. It's just instead of exporting positions and colors, we're just wiring through density. And we could wire out any other type of volume we want. But in this case, we just want to divide this density by 10 so we can get a similar result as what we had on our smaller scale. So if I do that, I'll just do a multiply constant and just wire that in right here. And that multiplier will be 0.1. So now this density is represented in a way that is similar to how it was back when we were this size. So if I zoom in, you can see that looks like the right level of transparency compared to this. So that's just a little quick tip about how you can troubleshoot densities changing when you're scaling objects, because you could modify the density using the attributes in Redshift or Octane if that's what you're using to render on the other end. But I just find that this keeps things sort of consistent because we're leaving Houdini now and going into Cinema. I like to give Cinema the best I can, the best objects I can, so that I don't have to worry about tweaking so many things on the Cinema side. Because a lot of times I'm actually just giving these objects to somebody else. So I will now throw down a file cache. So similar to how I cached out this simulation in the beginning, I just like throwing down another file cache. You could use a file. I'm just I feel like comfortable using this node just because it kind of does it all. So I'll just name this something reasonable. I'll put it into its own VDB folder. And this is actually going to be a sequence. Where the Alembic was one self-contained file, this VDB sequence is actually going to be an animated VDB sequence. So it'll be one VDB for each file. So to do that, I'm going to, I'll just name it something like, let's just give it, we'll call this our VDB export, like so. And I will go up here and I want to just rename this file path a little bit. I want to give it under the VDB file, I want to do $OS, so that'll create a VDB export folder. Then I'll do $hip name, and then so that will give me a let's see if I go over here. Looks like I've got yeah, it'll give me a VDB folder. It doesn't look like it did not take my $OS appropriately. It's because I typed in $0s where I had to actually write OS. Funny. So if I middle mouse click here, you can see I've got lesson 6 VDB. Then I made a VDB export for this node, and then it has the actual file name and then a string for that. Now at the end of this, it still says bgeo.sc. I want it to actually be VDB. And again, the $F there is just to make a unique file name per each frame that we export. So here I can go and click Save to Disk. So all it's doing is it's just loading this geometry off disk, running through these conversions, modifying the density so that it reflects the proper scaling, and then exporting it back out into our directory as a VDB. So if I go over here and go up to my VDB, you can see that my VDB export has appeared and it is writing out all of these files for us. So I will pause the recording and come back when that is completed. All right, so now that that is done caching out our VDBs, you can see here I actually have opened up the old Pyro cache folder, And when I cached out these volumes with velocity and density, all and that stuff stored together, it got massive. So at the end, I was caching at about a gig per frame. Whereas now with this VDB, we've kind of stripped it all down to its bare bones, and we're only going in at like 144 megs per frame as we got to the largest size that it reached. Which, you know, there's still big file sizes, and I would get used to working with big file sizes when you're doing simulations. But yeah, generally this VDB is much more efficient, and yeah, especially once you strip the velocity off. So now that we have that, we can now pair this up with our Cinema 4D scene. So let's go back over here, and now if you're using Redshift or Octane, I think both of them support VDBs, but in Redshift, the way you want to do it is go to Objects and select a Redshift volume. I've got a Redshift volume here. I'm going to go into my path. I'm going to hop up to lesson 6 and go to my VDB folder, VDB export folder, lesson 6, and grab the first one, click open. Image is not in the project search path. Do you want to create a copy at the project location? I generally tend to say no. I just like it to leave everything where it was, especially if you do that and you don't bring the entire animation along with it, the next step won't work. So if I go into now animation, I'm going to select simple mode. By default, it's set to frame rate of 30, even though if I hit Control B, my project setting is set to 24 here, and Control D, my project is set to 24 here as well. Whatever reason, Redshift wants to be bringing in a 30 frame rate by default, so I'll say I'm just going to change this to 24 because that's what we're working with, and I'll click detect frames, and you can see it goes from 0 to 72. Gives us this nice box that is encapsulating our view here, and while we don't get as great of a preview as we do in Houdini, where this looks very much like something like Nebula, over here in Cinema we can still get a little bit of that. So let's go over here. I'm just going to go to the let's see, is it volume right here, and where it says preview off, I can actually turn this on to show points, and then I can just show, maybe try putting in values and powers of 10. So you can see with 100 points you start to make out some sense of the VDB in here, and then 1,000 you can really start to get a feel for it. I feel like this generally tends to, I think that it slows down my scene. I can't say for sure, but you can kind of get a view of what that volume is doing now. So I'm going to actually turn off the preview in general, and then we'll just hit another render to see that in action. So let's just go Redshift, render view. We've got it here. I'm going to just turn off, I guess it won't do motion blur if I'm doing the IPR, but because I'm not really interested in that anymore at this point, I'm going to just turn it off in case it is making calculations take longer. So basic motion blur tag under Redshift, disable that, and then I'll just, the other thing I have to do, if I hit render, nothing should show up. Yeah, it just shows up blank. I need to create a Redshift, a volume shader. So I'm just going to create a new Redshift material, and I'm going to choose volume, and I'll just drag that volume onto the Redshift volume. There we are. And still nothing happens. If I go to my my area light that I created, it is an area light now, even though it says it's a point light right now. I'm going to go to the volume tab and just turn up its contribution so that increases. I'm not seeing much happening over here. I think maybe it's just maybe my density is too low. So let's just hop into the Redshift. Oh, I haven't assigned the density. That's the other thing. So if I double click on my Redshift volume shader and go down here, my basic scatter channel, I need to select density from this little drop down right here. And now you can see it starting to show up in our scene. And basically from here, it's more or less just dialing in your settings to get them to look the way that you want to. So maybe I go back to my light and bring down the volume contribution a little bit, just so it kind of gets the hint of the fact that there's a volume there. Cool. So that is working, and it looks like it's scaled properly and everything. So that's great. All right, so that is how we can get our volumes out of Houdini and into Cinema 4D. And in the next section, we're going to look at how to get particle geometry out of Houdini and into Cinema 4D using Redshift proxy. So stay tuned for that lesson, and then that should wrap this chapter up.